Welcome back. Now, we know that we have an overlap box on our weapon, and right now we're overlapping quite a lot with our character. Now, you might have tried to run up to this particular object here and swing and see if you could draw a debug sphere at the location of the wall, and you were probably met with frustration as we don't get an overlap event. And that's because overlap events have to be configured. Remember, all objects have their own collision presets, and so we won't get overlap events unless we're overlapping with something that's supposed to overlap. Now, in our BP weapon, we have a debug sphere drawn at the actor location of the thing we're overlapping with. And if we're overlapping with something, that thing has to respond to overlap events. So here in the world, if we select this wall, for example, we can go to its collision presets. I already have collision in the search bar, so I see collision. And for one, generate overlap events has to be checked in order for overlap events to generate. But that's not the only thing. You see, we have the collision presets, and the collision responses have to be configured properly. So if the other component overlapping with this wall has a particular type, this wall has to be set to either overlap or block that type. Now, in our BP weapon, if we select our new weapon box component, we can check its collision object type under collision. And we see here that its object type is world dynamic. So if we select the wall in the world and look at its collision response to world dynamic, we see that it's block, and so we should get an overlap event. So if we go ahead and swing, now we see that collision sphere right down there. That's the location of this static mesh actor. Now this is great, but if we wanted to spawn some kind of effect, like if we hit the wall, we'd want to see sparks, or if we hit someone else's body, we want to see blood. Well, we can't just spawn those effects at that actor's location. As we see, this wall has a location down at its bottom left. So if we swing at it and we get sparks down there at the bottom left, that's not going to make very much sense. We want the actual location. So we want the exact location where we make impact. And for that, we're going to use tracing. So let's talk about tracing. In games, we can trace in various ways. One of the simpler ways to trace is by using a line trace. For a line trace, we choose two locations, a start point and an end point. And a line trace essentially draws an imaginary line from the start to the end. And if any objects happen to be between the start and the end points, as soon as we draw that line, as long as that object is configured to be hit by a line trace, that trace will hit the object and will generate something called a hit result. The F hit result type is a struct, and it contains lots of information that gets filled in when we get a hit event. So in the case of a line trace, we'll have the other actor, we'll have the impact point, an F vector representing a location in space, so we can use that information to do things, such as spawn blood particles, or if we're shooting a bullet, we can spawn impact particles and other effects. And if we have access to the other actor, we can damage the other actor, and so on. So line tracing is pretty simple. But we can also trace using shapes. This works very much the same way as a line trace. The only difference is we have our start and end points, and we draw a shape. We can make sphere traces, for example, where instead of an imaginary straight line, we sweep a sphere across space from the start point to the end point, effectively generating a capsule volume. And if any objects exist between the start and end point, and their collision presets are configured to be hit by traces, then our sphere trace will start at the start point and hit that object, and we'll have a hit result. And the hit result contains lots and lots of information, such as the other actor, the impact point, and a hit location. Now, the impact point and hit location sound like they should be the same thing, but there's actually a difference that matters when it comes to tracing 3D objects like spheres. You see, here's the difference. A sphere has a center, and when it sweeps across space and hits something, it'll stop just short of overlapping that thing And the hit location is the center of that sphere at the point of impact. The impact point, however, is the point where the sphere actually made contact with the other object. And this is oftentimes the location that we want when we perform a trace, especially with 3D objects. Now, we can trace with other shapes as well, such as boxes. If we have a start point and an end point, and an object exists between them, we can draw an imaginary box which will sweep across space and stop just short of overlapping that object. And of course, we get a hit result, which has information packed inside, such as the other actor, the hit location, the impact point, and so on. So sweeping is a great way to determine whether or not our invisible sweep has hit something. Now this is great because we have a sword, and our sword has an overlap box, and as we're swinging the sword, we may overlap with something, but our box will continue passing through it, and we'd like to know at which point the box started overlapping. Now we can figure this out by performing a trace. We can start at the base of the blade, call that our start point, and end at the tip of the blade, and call that our end point. And we can perform a trace, such as a box trace, where we sweep a box down the blade until it gets a blocking hit, at which point we can get a hit result and get the impact point of that hit result, and then we'll know exactly where the blade hit that other object. And once we have that impact point, then we can spray blood or whatever else we want to spray at that point, and it looks more realistic. So this is the approach that we're going to take in this game project. So let's do a box trace and see how it works. So let's go back into BP Weapon. And instead of just drawing a debug sphere at the other actor's location, we're going to perform a box trace. Now I'd like to have a start point and an end point, and I'd like to be able to control those. And if we want to add a component that's pretty lightweight and doesn't really have a mesh or anything visual, it just has a location, a scene component is perfect for that. So I can click Add in the Components panel and search for Scene. And if I select Scene, I'll get a new scene component, and I'll call this Start. And I'll take my Start scene component and move it down to the base of the blade. Now I can add a new component, also of type Scene component, and I see that it's attached to my start location. I could just click and drag it onto Item Mesh, and now it's attached to the root component, which is the mesh. It doesn't really matter, but I can take my second scene component and rename it to End, and I can drag it up to the tip of the blade up here. So now I have two invisible scene components, one called Start down here and one called End up here. And I'd like to make a trace from start to end. So we'll see how to do this in Blueprints first before we move to C++. So I'm going to right-click in the event graph and type box trace. Now we have multiple types of box trace. We can box trace by channel, we can box trace by profile, and we can box trace for objects. Now objects is referring to collision object types, which we know about. And channel refers to collision channels. Let's select box trace by channel. And we see that the trace channel by default is visibility. The visibility channel is a pretty common channel for tracing, as most things are set to block the visibility channel. We kind of think of it like anything that you could see could block the visibility channel. If it's invisible, then you would not block the visibility channel. And that provides us with an easy-to-use category, and if we do line traces against this channel, we can be sure that we'll hit anything that we could see, provided that it's set to block the visibility channel. And if we make sure that things that we can see block the visibility channel in general, then we'll get a hit. Now, we need a start point and an end point for our trace. So I'm going to take my start scene component and drag it out, and from start, I can call the function getWorldLocation, and that returns a vector which I can plug in to start. And I can get my end scene component, get its world location with getWorldLocation, and plug that straight in to end. And now we have a start and end point for our box trace. Now half size refers to the distance from the center of the box along each axis. And there's an X, Y, and Z. These are like box extents. So I can make a box with, say, 2.5 for X, Y, and Z, and this will be a relatively small box. Now, we can visualize this because Box Trace by Channel has a Draw Debug type. And if we select for one frame, we'll draw it for one frame. If we select for duration, we'll draw it for a specific duration. And if we select persistent, then the debug shapes drawn by this will persist. I'm going to choose for duration, and if I expand the drop-down, we have a trace color, a trace hit color, and a draw time. And the draw time is 5 seconds. And we'll see what this looks like once we start tracing. So what I'd like to do is as soon as our weapon box overlaps with something, I'd like to perform this box trace by channel. So I'm going to hook this up, and we can just see what happens. So I'm going to compile, press play, and grab the weapon. Now, right away, I overlapped with the box. So we got our debug drawn for our trace. And if we run up to the wall and swing, now we see that trace in action. Now, it's red up to the point where the box trace hits something, at which point we see green. So this is a nice way to see if we hit something and to know the impact point. In fact, we can draw a debug sphere at the impact point because the box trace by channel has an output called outHit, and this is a hit result. In C++, it's an fHit result, and it's a struct that contains lots and lots of variables about the hit. If I click and drag it off, we can see all of the variables in this struct by selecting Break Hit Result. Now, it doesn't look like a lot of variables, but there's a drop-down, and if we expand it, here we see all the important variables in a hit result. We have a location, which is the center of the box when it hit, and most importantly, we have the impact point, and we're going to draw a debug sphere at the impact point. So let's use Draw Debug Sphere. And I'll hook this up, and for the center, we'll use impact point. For the radius, I'm going to set it to 25. For the duration, I'll set it to 5 seconds. And for the line color, I'll make it red or pink. Now, if I compile and go ahead and hit play, I can run up to this wall. And now I see the impact point where I'm hitting the wall. So this is great. Now, there are some nuances when it comes to both overlap events and traces. And we're going to see those nuances right now. Let's say that there's another object in the world, and perhaps it's a character, and it has a capsule component, and it has a mesh. What happens if we hit that? Well, we can see what happens by taking our BP/ character and dragging one into the world. Because this particular type of actor has a capsule component, and it has a skeletal mesh. And those have their own collision presets and responses, particularly to the visibility channel. So if I press play, what happens? Well, if I grab a weapon and I go and swing, we do see that we're getting a sweep. But the sweep isn't really hitting anything. It's not getting a hit result. So we need to find out what's happening there. For one, we see that that sweep isn't even reaching the mesh. And that's because the capsule component on this other / character is triggering an overlap event. We can hit tilde and show collision and swing the sword, and we'll see that it's actually hitting that capsule component. Let's see if I can hit with the other attack. Here we go. There we go. We can see that it's getting an overlap on the capsule. So that's one. And if we want an accurate hit where we're actually hitting the mesh, we don't want that capsule to generate an overlap event with our weapons box component. Now, rather than going into BP/ character and tampering with the capsule, which is pretty much set up to handle things correctly, we don't really want to go into its collision presets and change things. Instead, we can go into our weapon and select our weapon box. That's our box component. We can change the collision presets for that. So if we go to collision, we can take a look here at what's going on. Now, by default, its collision enabled is query only, its object type is world dynamic, and it's set to overlap all other types. And generate overlap events, of course, is checked. Now, in the character class, if we select our capsule, we can see that its object type is pawn. And if we select our mesh and look for collision, we see that the collision object type for the mesh is also pawn. Now, these are for the default values of a given BP/ character, but this instance in the world is different, and we can change properties on this instance in the world without changing the default blueprint, as this is just an object of the BP/ character type. So we can select its mesh component and go to its collision presets and change its collision object type. Now, for the collision presets for our weapon box, we can change it from overlap all dynamic to custom. And now these things are not grayed out anymore. And if we wanted to ignore the pawn type, we could. Now, our / character has a capsule and a mesh both set to the pawn type. So if we do ignore the pawn type for our weapon box, then we won't even get an overlap event. So running up to the character, nothing happens, so that's not exactly what we want, right? But we could take this instance of the character here and change its mesh to something else aside from the pawn object type. So I'm going to select the mesh, and for collision presets, I'm going to change it to custom and change the object type to world dynamic. So instead of pawn, this particular instance of BP/ character has its object type set to world dynamic. Now, another thing I need to do for this particular instance of BP/ character is I need to check the checkbox for generate overlap events. So I can get an overlap event, which will trigger our onComponentBegin overlap right here. And once that gets triggered, then we'll do the box trace. So let's see how this works. I'm going to grab a weapon, run up to this character. I think I missed. And there we go. We're actually doing the box trace, but it doesn't look like we're getting a hit result. So let's take a look at this instance. We'll select its mesh, and let's see its response to the visibility channel. You see, we're tracing with our box against the visibility channel. And that means if anything in the world is set to ignore the visibility channel, it will not get a hit from our box trace. And it just so happens that, contrary to what I said earlier, when I mentioned that things you can see should block the visibility channel, well, it looks like the mesh does not. So for this particular instance, I'm going to set it to block the visibility channel. And that should ensure that we get a hit from our box trace. So now if I grab a weapon and swing it at this character, now we get that box trace hit. And we're drawing a sphere at the impact point. So that's how we can get an accurate impact point when we're swinging the weapon. And in addition to that, we have all sorts of information from this hit result. We have the hit actor, which means we can access that actor and do things to it. So if I take this hit actor, I can print the name of it. In C++, the function is getName. In Blueprints, it's actually getObjectName. So if we get the object name, we can use printString. So I'm going to print string, plugging in the object name of the hit actor. And now if I run and hit something, now I see BP/character up at the top. And if I hit this wall, I see floor 0 because that's the name of that wall. So this is great. We now know how to get an accurate location when we're hitting something. And that's going to come in handy for combat. But of course, this is all in Blueprints. We want to do this from C++, and we'll do that next. Great job. I'll see you soon.